Right, I think we're live. We'll start in a few minutes. I need to set up a few things. Right. So it is all set. As always, if you have any question, please post on the chat, and otherwise we will start pretty soon. Right. The question can be anything from lab 6, lab 5, or homework 3. Alright. Haven't seen any question yet, but I guess I will start with number 2 on lab 6. So it's not much difficult. We just have the function, but not like polynomial we have that. Although we can use the product rule, I think it's better just to multiply it out, and then we'll try to find the maximum. This question asks for the maximum. Right. So I will multiply it out. Just copy the problem first. Now I multiply it out. X plus 1 squared so multiply x plus 1, x minus 2. I have to do those two first. Will be x squared minus 2x plus x minus 2. Right. Alright, so we have that. Then multiply it out again. Right. X cubed minus x squared minus 2x plus x squared minus x minus 2. X cubed minus x squared minus 2x, x squared minus x minus 2. Right. Combine like terms, x cubed, x squared and x squared look like cancel out. And then minus 2x minus x or minus 3x. And then minus 2. Right. Right. Then we'll have the function. So pretty much kind of like function like that. But this time we need to do a little bit of work. So to find maximum and minimum, we'll need to do 2 steps. First, we find the critical numbers, but actually just a partition number. So, right. Critical numbers in that domain. So we'll take derivative 3x squared minus 3 and then equal to 0 does not exist. Equal to 0, we just have the function, 3x squared minus 3, that's the derivative, equal to 0. So add 3 divided by 3, we have x squared is 1. So x will be equal to, don't forget that if we take the square root on both sides, there will be a plus or minus. That will be plus or minus 1. And does not exist. This derivatives continue defined everywhere, so we do not have anything here. Right. So we found the points 1 and negative 1. Next, in the step when we try to find the maximum and minimum, we will put in the table. Note that we have x equal to 1 and x equal to negative 1. I may just write this out first. So all the points that we need to check, the end points, just write the candidate here. The end point will be negative 2 and 1. And from here we have negative 1 as well. And 1. But we already have 1. So those are the points that we'll check. Right. And when we check, we're going to put in the original function. We can use this one or this one. That's the same. I use the original one. Right. This we can use the calculator. Let me find it. Right there. Yes, I just put there. Right. So we'll go to the list. So hit stat. And the first one, edit, hit enter. Those are the numbers, negative 2, negative 1, and 1. And then the function. Very careful on this one. We have to highlight the list 2, L2, and then we enter this. But instead of x, it's going to be L1. L1 plus 1 square, and then L1 minus 2. maximum it will be 0. Check real quick. Right. That's the maximum. Let me put the calculator. Right. So that's what we have. So we write, never mind. Maximum equal to 0 at x equal to -1. Be just like that. Right. Once again, I encourage you to put any question that you have on the list. Otherwise, I just pick random question. So, pretty much that. No, I didn't check email. I checked email like 2 hours ago, but I didn't see anything. So anyway, actually, I constantly checking the chat. So I hope that you can send the question again. I mean, put the question again. Otherwise, cannot see. Sorry. Okay. Because right now checking email kind of not a good time. Sorry. The next question we do is probably on left 5. A question with the box and then number 4. That application problem. Do you have number 4? Anyway, usually when we have this lab, then we're going to have this question because it's kind of long. Need to zoom out because this takes a lot more space than whole page. Right, so what we have, the box open top, let me just that the volume open top and twice long as is y. So pretty much if we're going to write the box, the open top and the volume is 36 feet, and also kind of important, well, twice as long as it is y. So if we have x here, then this will be 2x, and then we have the height, right? The volume is the length times width times height. So in this particular problem, we're going to have x 2x times the height. And that equal to x squared h. Right. and that is the volume. The volume is constant, fixed to 36. Right. So leave that in a moment. All right. The main question is not that. We want the dimension that require the minimum amount of material. That is the question. So to make this box, right, so I got that list, yes. Keep that in mind. Right, so to make this box, after this problem, well, we'll go with that. We will have front and back, left and right, and the bottom, because there's no top. So the material, or we just, in this case, we just what do we need to make the box. So that would be the surface area. So will be, again, front and back, left and right, and bottom. Front and back, left and right, and the bottom. Right. If we're going to write out surface area, front and back we have 2x times h. Yeah, I saw that too. We have some drops. Are we back online now? Sorry. Yeah, I saw that too. Right. So put all this together, we will have 4xh. Actually, make it 6. So we have that. Right. The only problem here is we have both variable x and h into the function. So to simplify things, we need only one variable. So good thing is we have from this equation, if we solve for h, we will have h equal to 36 divided by 2x squared will be 38 over x squared. Right. So we're going to substitute that in for h. We can only have one variable here. All right. So we do that, we should have 6x. I don't know why I changed to 38. Sorry, that 36. I mean 18. Sorry, 36 and 2 reduced to 18. That is 18. Right. And then we'll simplify. X and x squared cancel out. I mean cancel one of the x. We have 6 times 18 on the top. And need calculator with me. Wait, 108. Right. Finally, we have a function 108 plus 2x squared. That is the function need to be minimized. As we write to be minimized. Right. And then usually for this problem we should have the boundary when we look for the maximum and minimum, but when we have the limit like this, kind of difficult to set up boundary. So keep that in mind. We have to consider, go back to that. But now we have the one function of one variable, we can go from there. So the problem is minimize the function s. Right. So to do this problem, we do the two things that we did earlier. Meaning find critical numbers of this. Right, so we take derivative. Before we take derivative, we should simplify the function. Rewrite the function, that is x to the negative 1 plus 2x squared. Right, now we take derivative. It will be negative 108 x to the negative 2 plus 4x cubed. I'm sorry, 4x. Right. Next, we have x to negative power, so we move it down, become x squared, and then plus 4x. Common denominator, we'll multiply x squared top and bottom here. So we'll get negative 108 plus 4x cubed over x squared. Right, next. Derivative equal to 0. Derivative does not exist. Right. So negative 108 plus 4x cubed equal to 0. We solve for x cubed. 108 to that side, divide by 4. 108 divided by 4, I have 27. Right. Unlike the square root, for the previous problem, when we take the square root, there's a plus or minus when we have the square root. This cube root, we do not have the plus or minus. So only at even root we have the plus or minus. So if we take the cube root, we're going to have 3. X squared equal to 0, that's the bottom. We have x equal to 0. So derivative equal to 0, meaning the top is 0. And we let the top equal to 0, and we have x equal to 3. Bottom, x equal to 0. Right. One thing though, since this is the dimension, x cannot be equal to 0, otherwise we cannot have the box. So only one value we have is 3, and that is very important. Let me just write that fact out before we continue. Only one critical number. Right. So, which is x equal to 3, by the way. Now, if it is one critical numbers, we can do the sign chart instead of a table. So if we put on the sign chart and derivative -108 plus 4x cubed over x squared. So I just put that here. X cannot be negative or 0, so we start from 0 and to infinity. The point we have is 3 in the middle. Right. Next, we'll do the test point. I pick a point here and do different colors. A point here and a point there. So this is the derivative. If I pick a very big number in it, it's going to be positive. If I pick a small number, the negative 108 is going to be bigger, so it's going to be negative. So the graph will go like this, which confirms this is the minimum. So because it is the only critical number, the local minimum is also local absolute minimum. So local min is also absolute mean. Because of this, it is the only critical number. Right. So we know the absolute mean will be occur at x equal to 3, with occur at x equal to 3. And finally, put it back into this box. We have the dimension will be x, 3, 2x, will be 2 times that will be 6. And then 18 divided by x squared is h. 18 divided by x squared is 2. So the dimension is 3 by 6 by 2. Dimension of the box. Right. So I keep that there for a minute while I go back to the list of questions. Instead of go to lab 5, number 5 as a question on the chat, I'll go to lab 6, number 4 first, because we're still on the same topic. Right. So that. So it says the price changes that. So in thousands of candy bars. And we have the price is given by that, where x is, in this case, will be the quantity. You can zoom back in. Right. So we have how many candy bar must be sold to maximize revenue. So we don't have the function directly. First we have revenue is the price times quantity multiply quantity. The price is that. The quantity will be x. Right. I'll multiply it out. 104x minus x squared over 34. That is the function, the revenue function, of course, to be maximized. right? Next, I will rewrite this so it's easy to find derivative and do other things. Let's rewrite like this instead. Right, now usually there will be a boundary for this problem, but kind of like the last problem, quantities, any measurement cannot be negative, so it's going to be 0 to infinity. In this case, we use a little bit different method though. Right, so again, we'll find a critical number. And the critical numbers in this case should be from 0 to infinity. Anyway, so we check derivative. Will be 104 minus, that will be just 2x. 1 over 34, 2x will be 1 over 17 once we cancel out. Right. Next, we will let that derivative equal to 0 and then does not exist. This, we actually, before that, we can do the common denominator, multiply by 17, top and bottom here. I got 1768, so I multiply 17 here, divide by 17. So it will be 1768 minus x. So let the top equal to 0. The bottom cannot equal to 0 because it's only 17. So the derivative equal to 0, the top is 0, derivative does not exist, bottom is 0. There will be none here. So I have x equal to 1768. Right. Next, we just need to confirm that it is actually a maximum here. Again, we only have one point, so once again I will write only one critical number. That. Next, we just need to show that it is the maximum. The way we do that, unlike the last problem, where we have the derivative, it's like this. If I have to take derivative again, it will be more complicated. However, this problem, the derivative is this. 104 minus 1 over 17x. Taking derivative is extremely easy thing to do. So all we need to do is use the second derivative test, and that is background. So I take derivative again from here. Second derivative, if the first derivative is 104 minus 1 over 17x, then the second derivative is just negative 1 over 17. Regardless of the values for x, this is going to be negative for sure. If it's negative, meaning it open down, and open down, of course, there will be the max. So it confirmed that this point is where the maximum at. So this point is where the maximum at. So good thing here is, we can take second derivative. So when we try to find the maximum, minimum, and confirm that it is the maximum or minimum, if we use the sign chart, where we cannot take second derivative, or it's more difficult to do so. Here we take the second derivative with only one step, so we should use the second derivative test. And since only one critical values one critical number, local max, is also absolute max. So we say local and absolute max will be at that point. Right. The only thing need to pay attention on this problem, X is 1,000 candy bars, so it actually is D and not going to be A. The number is still the same, but it should be thousands of candy bars. Right. So lab 6 number 2. Actually, that is actually the first problem we did, but so for some reason the video was down. So I'm going to show that quickly, and then later on when I post the video, I have to draw the 2 videos, then I upload again. But here it is. Yeah, just sleep here for a moment while thinking what will go next. But that was that. Right, so all of this, trying to find the maximum or minimum critical number first, and then put in the table if we want to. If we have the boundary, the table would be a way to go. For the work problem, usually when we do not have the boundary, if it turns out that we only have one critical numbers, then we can use the first derivative test, meaning the sign chart, or we use the second derivative test, like we just did on the last problem. Right. Sorry, I did this problem, and then the stream went down. I guess I have to fix that later. Right. Next, so look like that on the absolute max and min problem that we're going to have. Next, I think we go to lab 5, 5A and 5B. So this is the elasticity of demand. Right. So we have the demand function such and such, we're going to be equal to this. So first we need elasticity of demand. Sorry, need to update the list. Right. Elasticity of demand will be a function of the price when negative of the price times the function divided by the derivative divided by the function. Right. So this is the function, by the way. So for this problem, we're just going to put e of price negative p. Derivative of this is negative 0.22, and the function itself negative and negative will make a positive. Right. Next, we're going to put 1. By the way, that's pretty much it. Next, we're going to put 166 into this and see what happened. So, at 166.1, yeah, just check, make sure the number is not too small. Right, so we just do that math. Calculator. Right. Let's quick this. Alpha y equal to the bottom menu pop up, and we have 0.22 times 166.1 divided by 55.2 minus 0.22 times 166.1 have 1.95. Right, so, and this is greater than 1, so the demand is elastic. Right. I need to, okay. Next, which means, of course, if it is elastic, then we need to think a little bit. Let's just write it down again, just like last time we did in class. It will be like this, where we have this much, meaning whenever the price change by this much, the demand will change by, sorry, I should write it out instead. So here the demand, sorry, start with the price, and here we have the demand, which gives us the quantity. Right, now I'll do this, and then after this we can choose easily. If the price increased by 1%, then the demand or the quantity demand will decrease, because the higher the price, the less likely we want to buy it. To increase by this much. If the price dropped by 1%, it will increase by. Now, the revenue is the price times the quantity. So if we have to pick which one will give us the more net positive. Okay. By the way, you do see the list of the question on the top, right? So those are the questions that I already did. So I'll go back to that if need to. Right. So on this one, clearly we're going to need to pick this, because that will give us more positive. So in this case, we see the price should decrease, so the revenue will increase. So because it is elastic, it has to go on sale if we want to increase the revenue. Right. So do have quite a few questions on the chat. I already did lab 5, number 4. I'm going to turn the page to previous quickly. So that was number 4, by the way. Yeah. So this is number 4 on lab 5. If you want to take a snapshot, do that, because I'm going to go to the next one. I already did that. Let's see. Lab 5, 2. Right. So we have 5. I'll go back and forth, just make sure that what we've been doing. Right. I do have a question number 2 on lab 5. This should classify as the maximum or minimum. So kind of the same thing. Let me. So, sorry. Last question we have this. The next one. Those two questions are extremely similar, so I'm going to only do one of them. By the way, I see the list of the questions, and of course, I will go through that, and then but I try to keep all the questions in the similar topic, kind of close together. Right. So the next one, of course, is lab 5, number 2. By the way, this could be a long video, so but I try to go as much as we can. Doesn't have to end at 7. Anyway, so we have the function. When we find the maximum or minimum, there are two things to be done. First, the critical number. And next, the table, the sign chart, or the second derivative test. A lot of things to determine maximum or minimum. Right, so this is the function, right? So we need to take derivative. I will rewrite that as 9 minus x minus 9x to the minus 1 negative power. So we take derivative. Derivative of 9 is gone. Derivative of negative x is negative 1. Negative 9x to negative 1 is the plus 9x negative 2, which equal to negative 1 plus 9 over x squared, right? Common denominator, x squared over x squared negative x squared plus 9. Right, so two things. Derivative equal to 0, which means if there's a fraction, the top must be 0. Derivative does not exist if it's a fraction, so the bottom is 0. Right. Right, negative x squared plus 9 equal to 0. So x squared equal to 9 if we move the x squared on that side. And then again, when we take the square root on both sides, don't forget there will be a plus or minus. If it is cube root, like number 4 on this lab, no plus or minus. Only plus or minus on an even root. Plus or minus 3. And here the bottom equal to 0, x squared equal to 0, so we have x equal to 0. Right, next. Good thing in this problem we are given that x must be greater than 0. So the negative 3 doesn't work, the 0 doesn't work, we only have 1. It's x equal to 3. So critical point, let's see. Critical numbers for x greater than 0, as we have here, only one of them, x equal to 3. Good thing the negative 3 doesn't work in here, the 0 doesn't work in there. Right. You can see that lab 6 number 3 will be similar to this. Right. Next, what we do is going to see what happened there. So before we continue, the next one is to determine whether we have the max or the min here. So since we only have one critical number, so we write, it's very important, let me just write that again, only one critical number. If it is only one critical number, the local max is also the absolute max, local min is also absolute min. So in that case, will be a lot of different things we can do. I will use the sign chart. Simply, I just want to take the second derivative of this. Yeah, I want to take the second derivative of this. So we use the sign chart. Remember, we can only do this if we have one critical number. If it is not, we cannot. We just have to use the table. Like this. If we have more than one critical number, use the table. We can use the table here too, but I think in class we did differently. But this time, just do the sign chart. For x greater than 0, meaning it goes to 0 to infinity, and 3 will be right there. Derivative is negative x squared plus 9 over x squared. Decimal, I will choose 1 and then 5. If we put 1 in here, clearly the top is negative, the bottom is positive. So it's negative and then positive, meaning going down and then up. So here we have the minimum. Since it is only one critical number, local mean and absolute mean at x equal to 3. If we put 3 back into this problem, 9 minus 3 minus 9 over 3, so that's like equal to 3. If you put 3 in for x, that will be 6 minus 3 will be 3. So the y value is equal to 3 at x equal to 3. And if we go like this, especially to infinity, we're not going to have a max. Because only one critical number and it is unbounded on both sides. So there should be no max. Right. Right, so that's that. Right, wait. Let's see what's next. Right, pretty much I have the whole request for the whole lab 6. So I cannot do all of that. I'm going to pick some from on some topics and then let's give you some guideline what to do the others. Now look like we have all the lab 5 cover. I'll just go to lab 6. Right. I said I have all the questions from all the lab 6 I cannot do all of those, but some of it. Right. At least on some question, let's get you the formula and where you start with. All right. This one, elasticity of demand, number 5. Right. Since I'm not going to finish the problem, I just go start with elasticity of demand, negative times the price times derivative divided by the function, where this is going to be the function. Right. Right. That's fine. Right. So on this one, negative p is the price, derivative negative 4 over the function. And then we're just going to put 80 in it. Right. Whatever that is, I'll let you do the math there. Right. So next, we go to either 6 or 7 and then 8. Those are implicit differentiation. The next part is this. Right. So number 6 is actually easier than 7, so I go with the more complicated problem. Right. But overall, those two questions, we asked to find dy over dx, meaning that y is a function of x. So if you take derivative, put a box around y. So we take derivative. This will be 4 over 3 x to the 1/3, and derivative of this 4 over 3 y to the 1/3. The only difference between the x and the y is that y is a function of x, so we're going to have the dy over dx next to it, or the y prime if you choose to do so. So derivative, if it is x, the same way. If it is y, we have to have this, since y is a function of x. And derivative of 1 is a constant, so it's going to be 0. Next step is you just need to solve for dy over dx. I'll let you do that. And at the end, you get dy dx over dx by itself. Right. Now we do a complete problem. 7 is that. Like I said, I cannot do the whole lab. Right. Now this, still the same thing. Y is a function of x. By the way, when we do this, the arrow, that means we take derivative with respect to x. Now we take y as a function of x. Right. So we take term by term derivative. Again, derivative of y squared is going to be 2y and then since y is a function of x, now this is a little more complicated because 2x is a function of x and y is another function of x, so we have to use the product rule here. So u equal to 2x, v equal to y, and u prime equal to 2, v prime equal to 1. The only difference, once again, every time is y is a function of x, we have to stick the dy over dx. For the x, there's nothing, just like we normally do. Right, so we have a product rule here, so let's say it. It's a minus here. So u prime will be 2, v be y, and u will be 2x, and v prime will be that. So we have 2y plus 2x dy dx minus 2y dy dx, sorry. And derivative, so derivative of this product rule is going to be that, and then equal to 1. Derivative of 1, sorry, is 0. Right, what we do next, we're going to move the 2y over. And since both of these have dy over dx, we'll factor the dy over dx out. Inside we will have 2x minus 2y. The 2y already on that side as negative 2y. Right. Next, just need to divide both sides by what inside this bracket. Right, that is the answer. By the way, if it is a multiple choice, of course you don't see that. So the problem, we don't see that because the top will be just y, so we move the negative down actually. So it's going to be 2y on the top. The bottom, we carry the negative sign now. Right, and then 2y. Here I can bring out the 2. Just the 2, the sign and everything stay the same. The 2 will cancel out. So we have y over negative xy, negative x minus y, sorry. And distributed the minus, we have negative x plus y, which is y minus x, will be that. Right, so this one a little bit more complicated than 6, but ultimately we take derivative. If there's x, will be the same. If there's y, stick to dy over dx to it, and get it by itself, and then we have it. Right. Next we need 8. Because different kind of question. This equation of a tangent line. So equation of tangent line, let's start from y minus y1 equal to m x minus x1. M is the slope. In this case, we are given the point 4 and 1, so we can write y minus 1 equal to m x minus x1. Just need to determine what is m. Right. To do that, we did kind of like what we just done on 7. If this is the function, we assume that, by the way, m is the slope, which is of course is the derivative. Right. So in this case, y is a function of x, just like the last problem. So assume y is a function of x. So we have, this is the product, so the product rule derivative on that side will be 0. Right, so we differentiate with respect to x, so derivative with respect to x. Right, so u is going to be x, so just put that here. V is going to be y squared, right? U prime derivative of x is 1. Derivative of y squared will be 2y. But once again, y is a function of x, so we have to stick the dy over dx to it. So which means y squared plus 2xy dy over dx equal to 0. Right. Of course, we can get dy over dx by itself, but I'm just going to put 4 and 1 in for x and y here. So I'll say to add x and y equal to 4 and 1. Put 1 in for y, 4 in for x. Y over dx equal to 0, and that we will have one plus 8 dy dx equal to 0, minus 1 divided by 8, so dy dx is equal to negative 1 over 8. I just cheat and look at the problems, the answer, and see if actually that look right. Right. Next, that's negative 1 over 8 is the slope that we looking for earlier. So we put it back. By the way, x1 is 4, so we know that already. Right, and just simplifying, we'll have y minus 1 equal to negative 1/8x. That will be plus 1/2. Plus 1, so we will have y equal negative 1 over 8x plus 3/2. So the answer is right. Yeah. So I'll just take derivative to find the slope. The point will be given. Right. Next we look at 9 and 10. Not both of them, but The more difficult one would be number 10. So I will look at 10. It will be extremely similar when we do it. Alright, so first, of course, those are not the same. One looks easier, one with the square root. So first, we need to take care of the square root. So we're going to square both sides. When we do that, we will not have square root anymore. Right. When we do that, the problem will be pretty similar to this. Right. The square will go to y, and the square will go to the square root, and 144 on the other side. Square and square root cancel. Y square x plus 1 equal 144. And then we multiply it out. Will be xy square plus y square equal to 144. Right. Now to see those problems are almost the same. Now, the difference between this problem 9 and 10 compared to the previous one, this time notice that what we are asked to find is dy over dt. So the new thing is, of course, the t is the variable. So t is the variable. So, and then we also have x and y a function of t. So meaning that every time we take derivative, this is x, we stick the x over dt, for y, the y over dt. So I'm going to write derivative on this side. Now we have x y square plus y square equal to 144. And once again, x and y are a function of t. Now we take derivative. I do this one first. It will be 2y and then dy over dt. Because x and y are a function of t, we have to put that in for dy for y and then for x. This, both of them are function of t, so we can just u prime okay, what is u? So it could be x. Then I can zoom back in because I'm a little small here. I write a little small there. Alright, so u is x. Actually there's space here, so u is x and v is y square. Take derivative is 1, but then again x is a function of t, so dx over dt, and then v prime 2y, again y is a function of t, dy over dt. Sorry, I have to write kind of small here. Right, so u is x, v is y square, so here we have u prime is just dx over dt, and v prime will be dy over dt. The other side, derivative of 144 will be 0. So let me simplify this a little bit. We have y square dx over dt 2xy dy over dt. And then 2y dy over dt. Yeah, need to adjust the focus a little bit. It looked a little blur earlier. Right. Now we just have all the values. Dx over dt is 8, y is 3, so we put 3 square. Dx over dt is 8. 2xy dy over dt we don't know. And then 2y dy over dt equal to 0. Right, now just do the math. Notice there are 3 terms. And we just do each term. We do not combine all those numbers here. That would be terrible. Completely wrong. 3 square and 8 is will be 72. 2 times 15, 30 times that will be 90. 90 dy over dt. And this is 6 dy over dt. The 72, okay, we'll go to that side as negative. Combine those two. Those two terms both have dy over dt, so we can combine them. 96 dy over dt. And then negative 72 divided by 96. That's what we have for dy over dt. So simplify that by 24. Like that. The previous problem will be similar. We just take the derivative. If there's x and the function x and y together, that's the product rule. So if we have x, stick dx over dt. If we have y, dy over dt. So that. Next we have differentials. That is simple enough. I'm going to look at both of these problems. Right. So actually what we have here just we have x and dx, delta x. We just need to find the dy, so this is differentials. So let's start from the background. What we need is dy over dx is the derivative, which is different notation, is that kind of move the dx over. I said kind of, so not technically. And then we just make it equal to the derivative. The delta x or dx is the same thing. Right, so dy is equal to that. If we go to delta y, it will be approximately equal to. For dy, exactly equal to. Right, so pretty much take derivative times dx. So that is the function. So we say dy is the derivative times delta x. This is the function. Derivative of that will be 3x squared plus 2 delta x. And x equal to 2, delta x equal to 0.01. So that should be simple. So we just substitute in here 3 2 square plus 2 delta x. So whatever it equal to 12, 14, 0.14 is that C. So that's pretty much it. Just check guys. Right, next one, the same thing, pretty much, but we have the quotient rule is that. So just take derivative. So this is the function. We use the quotient rule, u equal to 3x minus 7, v equal to x minus 1, derivative 3, v prime is 1. Right, so just that. So derivative quotient rule, u prime 3, v x minus 1 minus u v prime is 1 over v square x minus 1 square. Right, multiply it out, 3x minus 3 minus 3x plus 7 3x gone, that will be 4 over x minus 1 square. So that is the derivative, and dy equal to the derivative times delta x. Derivative is that delta x. Just need to evaluate at these values. At x equal to 2, delta x equal to 0.1. So put 2 and 0.1 into it. So 2 minus 1 is 1, 4 is still 4, so 0.4. So it looks like that. Right. Square 45, 145. Actually, we did exactly, I mean, not exact number, but in the note and in class we did square root of 50, so this is extremely close to it. So we're not going to do 13. What we do instead is 14. Right, a little, I'll get to started on number 13 though. So usually for this problem, what we're looking for is the approximation, and the approximation will be approximation for the function f of x be at 8 plus derivative x minus 8. So be the same for both of this. Right. I'll do 14. First, whatever the weird number we see in the problem, it's only one number in the problem. We let that be x. Then we have the function is equal to ln of x. So that's what we always do. X is that number and then ln of x. What we do next is going to choose. We're going to choose something very close to this, and then we choose 1 because ln of 1 is turned out to be a nice number. Right, and then we write out the formula. Right, what we have A is going to be 1, that's easy. X is 1.04, also easy. Just need to find out the function we do have is ln of x. Now at x equal to a equal to 1, f of 1, ln of 1 is 0. So we have this 0. So that is for the function at these values. Now we're going to take derivative. So that two things need to be found. Derivative is 1 over x. When x equal to a equal to 1, the derivative at 1 equal to 1 over 1, which is 1. So this is going to be equal to 1. And put this together, the approximation would be equal to 0 plus 1 times x 1.04 minus a 1. So we just have 0.04. Right. On this problem, what we gonna let x equal to, of course, is 145, and we choose a to be 144. Yeah. And we do the same thing, same formula, find the function derivative at those points. Also similar to the problem we did in class. Right, so that's 14. And the last topic we have is the Harper rule, so we 15 to 19. Right. So all of it kind of important, except the last one is the easiest one. I think we need to do list of all of this. Right. Actually, we briefly go to the last one first. 19. As x goes to infinity, only the highest power matters. And then the x squared cancel, so that will be just right. So let's write a little note here. At x go to positive or negative infinity, the highest power term matter. I should write only the highest matters. Right, so we can do that. So that only works for infinity though. So for the previous 4 problems, I mean those 3 problems, we cannot do that. Right, the first one here, when we're trying to find the limit at the number, the first thing always put in that number and see what happened. If I put 1 here, the video is still okay, right? Look like my black. Right. So the top we give 0 over 0. Now 0 over 0 is indeterminate, meaning it could be anything. At the beginning of the class we can do the factoring, but this time we know the Harper rule, so we're just going to take derivative of the top, derivative of the bottom. This is not the quotient rule. We will never use the quotient rule for the Harper rule. Right, derivative 3x squared minus 16x over 1. Now that one, obviously, we're going to put 1 in there, and there should be no problem, because we just have 3x squared minus 16x. Where we put 1 in it will be negative 13. Right. Right. So this, again, the same thing. We'll switch different ink so it's easier to distinguish the problem. First, I'm going to put 0 in for x, and that's still 0 over 0 because a to the 0 power is 1, so write that somewhere. So 0 over 0, indeterminate again, we will use the Harper rule for that. Derivative a to the x is still a to the x. Derivative at the bottom, 3x squared. Then we're going to put 0 in it and see what happens. Right. So a to 0 power is 1. And that over 0. Now we have 1 over 0. Of course, that does not exist. Right, let's go over a few things first. Important thing for when we use the Harper rule, other than the powers. Let's go with something less obvious. When we have a to something that goes to infinity is infinity. When a go to negative infinity, it is equal to 0. The way to memorize that is the graph exponential function look like this. On one side go to infinity, on the other side goes to 0. There's ln2. ln of something that goes to 0, infinity will be infinity. ln of something that goes to 0 from the plus sign is negative infinity. The graph will be like this. On one side it goes to infinity, on the other side it goes to 0. I'm sorry, negative infinity when x goes to 0. And then we have a lot of, two more things. It will be 0 over 0 we know is indeterminate. So 0 over anything else is 0. 0 over, something not equal to 0 divided by 0 is undefined. Right, so that is 0. Infinity over infinity is indeterminate. Infinity, by infinity I mean plus or minus. Infinity divided by something that is not infinity, I just say finite, is still infinity. And the finite divided by infinity is going to be 0, plus or minus. This equals plus or minus 2. Right. So that's pretty much what we need to know for the Harper rule. We don't have to worry about that. On the test I would not ask that. But exponential, and then this. Right, this one, if we put 0 in for x, I mean 8 in for x, we have 0 over 0, which of course is indeterminate. So the hospital rule that is 8, not infinity. So we take derivative of the top and derivative of the bottom. Derivative of the bottom is just 1. Derivative of this, I will rewrite this as x to the 1/3. So derivative is this. That will be just and then we're going to put 8 in it. Right. Whatever that is, I don't know why I write 8 here, why it should be 3. Right. Whatever that is, it's going to be the answer. Right. So as long as we have 0 over 0 or infinity over infinity, those are indeterminate, and the Hospital rule will work for those cases. Right, e to the x over x squared. If we put infinity over infinity square, that will be infinity over infinity, by the way. E to infinity is infinity. Need to know that. Right, so again, this is indeterminate. Derivative of the top and the bottom. E to the x derivative is e to the x. Derivative of x squared is 2x. Right, do the same thing, put in infinity. We still have infinity over infinity, which still indeterminate. Which means we can still use the Hospital rule. The top is still e to the x, but the bottom is just 2 now.